Hello and welcome to my presentation on the Allianz Arena. During this presentation, an analysis of the Allianz Arena Munich will be conducted. It examines a complex building, in this case Bayern Munich's football stadium. An evaluation of its features, materials and construction techniques will be given. Furthermore, the structural, substructure and superstructure systems, finishes, services and sustainable considerations will all be given during this presentation. Firstly, this is just some background information of the Allianz Arena. During January 2001, FC Bayern and TSV 1860 joined forces to construct a new stadium, although a location has yet to be chosen. Eventually, the Frod-Manning district was chosen, however the citizens would eventually get the last say. During October 2001, a referendum was held in which the citizens voted in favour of the plans for a new stadium being built there. Also, the construction costs ran to €286 million. However, after financing costs, this figure raised to €340 million. However, the costs were eventually split 50-50 between the two clubs. It is important to note the key figureheads for the construction of the building. As you can see, the architectural design was done by Jacques Herzog and Pierre de Meuron, after winning a competition between 8 other architects. Additionally, the structure design was done by Arab & Partners, the lead engineer by Stephen Wilstein, and the schedule supervisor by AS&P. It is important to note these companies as they have contributed for the success that was the Allianz Arena. The quality. The stadium had to be of the highest quality due to the significance of the project, Bayern Munich being Germany's most successful club and situated in the capital city. With the World Cup in 2006 also approaching, all the eyes would be on this. So what was the concept behind the design and what were the main challenges? Swiss architects designed the concept of this work whilst fulfilled the FIFA regulations as well as the owner's desires. However, there was a major challenge since more than one team was going to use it. Within the design phases, this is a problem that was most challenging to the project. It was well known that the supporters of the football teams make their own home stadium an icon that reflects the character and the personality and its teams. How come two teams will feel identified with a single stadium? The solution the Swiss architects arrived at was effective and ingenious. It was to light up the stadium with different colours of each team during their respective games, which changes the appearance of the stadium altogether. From a distance, the building's skin resembles blown glass, but up close, the arena reveals itself to be covered in plastic cushions made from ETFE foil, a mere 0.2 millimeters thick, inflated by a constant stream of warm air. Now onto the bowl geometry of the stadium. The shape of the stadium is a very important feature that needs to be considered. The bowl structure was chosen for the Allianz Arena. The geometry of the bowl shape offers the sports stadium is improved in viewing ability for its spectators. When compared to other shapes for sports ground, this bowl structure is always going to come out on top. For example, square-shaped stadiums have poor viewing ability in the corner seats, therefore the bowl counteracts this. The bowl geometry will help the C value, but also the design will increase the viewing ability as well. Unlike other stadiums whereby the front row seats have poor viewing ability, this stadium's lower tier is steeper than usual to help this. As previously discussed, the C value was mentioned. Therefore, it was important to understand what this concept means. The geometry of a stadium can be defined by the sight lines of the spectators. Sight lines are defined by a C value, which is a measurement of the distance a spectator can see over the head of a spectator, below at an angle to the nearest point of focus. In football stadiums, so the Allianz Arena, this point of focus refers to the sidelines. A high ratio between the C value and the overall mass of the stadium impacts not only the cost of the stadium, but also the comfort of the spectator. Demanding a high C value can benefit spectators sitting in the lower tiers, who will have an excellent viewing experience. However, it may create an uncomfortable feeling of vertigo for fans in the upper tiers as the stands become very steep. It is important to proceed with caution to choose the appropriate C value for all spectators. A FIFA event requires a minimum C value of 60 millimeters. Now onto the time constraints of the construction. The stadium was under time constraints to be finished. The country was hosting a World Cup in the summer of 2006 and therefore had to be finished before this date, or it would have been seen a complete disaster for the whole country, not just Bayern Munich. To help achieve this date, a design village was even created close to the stadium. This allowed for more coordination and also a means of everyone contributing quicker to design solutions as well. Next, it is important to know the schedule of the construction process. This was conducted by AS&P. Here we can see the order of the work, starting from the preparatory infrastructure going, ending with the furnishing, fixtures and fittings. Also now the cost analysis. This slide mentions the cost analysis of the construction of the Allianz Arena. The total costs of the stadium reached 340 million euros, which is one of the most expensive stadiums in the world. However, it has also one of the highest capacities also, so a high construction cost is to be expected. From the table shown to the side of the slide, we can see that this is 4,864 euros per seat. This figure was relatively low when compared to other large stadiums. For example, Wembley Stadium was at 10,137 euros per seat. This figure is created by dividing capacity by the construction costs. Now we are going to move on to the substructure. There were potentially 23 sites that would be considered to be the new home for the football stadium. The old site was not an option after a critical site investigation. Frot Manninger was located on the outskirts of the city, meaning there was a lot of space to build a new stadium. The site also had the best infrastructure for the stadium as well as ground conditions. It is located near an autobahn, meaning lorries can easily access the construction site, as well as supporters once the stadium has been built. This could also offer emergency vehicles the opportunity for quick access in and out of the stadium. Next, we move on to the foundations that were used during the construction of the stadium. Precast concrete driven piles were used for the concrete pillars that supported the superstructure, with pad foundations being used for the bowl structure of the actual stadium. Firstly, we will comment on the precast driven piles. Precast driven piles were used for the construction of the stadium. This type of foundation will be driven into the soil using a hammer and a crane. This will provide the stadium deep soil support for the stadium, which is needed for such a large project. Then the foundations will be poured onto the pile system, transferring the loads of the stadium from the columns through the foundations and then to the piles. Within this stadium, 880 tons will be placed onto the foundations. The foundation has a loading capacity of up to 1,500 tons. Therefore, the foundation will be very structurally stable. We must then evaluate this type of foundation. As we can see from the advantages, this foundation could be prefabricated off-site. This means that it will save construction time on-site and be quickly assembled. This is not the case with other foundation types, therefore a big bonus for using precast-driven piles. Additionally, this means that it is a very cost-effective option to pursue when compared to other foundation methods. The superior strength this foundation uses is also what is key for this project. The strength is further increased as the process of driving the piles into the ground will compact the soil. Additionally, from the table we see from the slides, disadvantages are given as well. However, these are important to consider to fully evaluate this foundation type. Some of the disadvantages do not affect this project though, so can be dismissed. For example, the noisy installation will not be a problem as it is in the outskirts of the city, not surrounded by any residents. Also, the location is next to an autobahn, so sound will be drowned out that way anyway. It is also not suitable for sites with poor drainage, which this site does not suffer from. Also, advanced planning will not be an issue as it can actually push the project to be more organised from the get-go. Pad foundations. Furthermore, pad foundations were also used in this stadium. The pad foundations were used on the bowl structure of the stadium. This type of foundation is very cost effective also, meaning investment can be given to other parts of the construction project. There will also be no chance of differential settlement. These are all the reasons as to why pad foundations will be used in the allianz arena. Now we're going to move on to the superstructure of the allianz arena. Firstly, we will examine the bowl structure. The bowl is divided into 8 individual structures due to enormous forces from shrinkage, temperature effects, and the frame would not have been coped as a single structure. The structural elements of the stadium bowl comprise suspended floor slabs, wide and shallow floor beams, precast terraces, deep raking beams to support the tiers, columns and large pad foundations in a variety of sizes and depths. Now we must comment on the frames, columns and beams that make up the bowl structure. The columns are also mainly cast in grade B45 concrete, though for some higher stress columns, the greater strength of B55 had to be employed. The circular columns at the back of the bowl are of special spun concrete type, fabricated in Switzerland and delivered on site with connection plates at top and bottom. These act as tension ties to hold down the cantilever steel roof. They follow the curved facade line, changing direction at each floor level and thus imposing additional horizontal forces on the frame. Now onto the precast terraces. For aesthetic reasons and speed of construction, all the terrace units were precast, spanning between the raking beams as simply supported beam and slab elements. To avoid excessive stresses on the main frame from thermal expansion of the exposed precast elements, one of each end of the unit is on a sliding bearing. The elements are connected to each other at the sides with dowels along with other contact edges. The connection ensures that no gaps arise between the step and the riser, and the elements jointly carry the gravity loads. Now onto the suspended floor systems. Generally, suspended floor systems resting on downstand beams were used for the structural slabs, as it was necessary to create the much needed frame action. However, the contractor asked for flat slab solutions where possible to reduce construction time, and there was also widely used in the lowest levels. Elsewhere, the contractor also requested precast slabs with concrete topping to reduce formwork costs. Now we move on to the structural system of the allianz arena. First, we'll comment on the skeletal structure. There were 2 different load-bearing systems used in the allianz arena. Firstly, there was a cantilevered steel lattice girder used for the primary structure of the roof. Also, a rhomboid grid of steel girders was used, varying in sizes from 2 by 7 meters to 5 by 17 meters. The rhomboid grid will allow natural strength due to its shape, as this and triangles offer great strength. Within this section, a steel lattice structure was used. This was also used in the roof, consisting of 50-meter cantilevering steel framework trusses made in a lattice manner. These were then supported by concrete pillars. This method of structure has many advantages for the allianz arena. For example, it has great strength quality that would be vital for the roof. Also, it is very durable, meaning the club won't need to worry about the constant maintenance costs that would otherwise be needed. The lightweight nature of it is also a bonus for using steel lattice structure. Furthermore, its high elasticity is vital due to the height of the stadium. It will need to support the roof, and at that height, strong winds can occur. Although it must be commented that there is a high maintenance cost when a problem does occur. Also, the lattice structure is prone to corrosion, so that is an important note to make. Now onto the facade. Once is generally considered as the most iconic and striking feature of the allianz arena is the facade. The facade is made from FE pillows that will illuminate from LED sensors hidden behind the cushions. The translucent nature of the FE pillows means that they can individually be lit up to give that iconic imagery that the stadium does give off. The translucent nature of the cushions is created due to its small thickness, only being 0.2 millimeters thick. There were 2,874 diamond metal panels used at a pressure of 35 HPa. The cushions would be inflated using constant warm air being pushed against it, creating enough air pressure that would make them stand up almost. There are a lot of benefits to using this facade also. The material is prefabricated, meaning that there is a quick assembly. Also, it is cheap when compared to other facades. The FTE material, despite its thin nature, is highly tear resistant, which is an important note to make. Furthermore, it is lightweight, and due to its prefabricated nature, this will help the transportation costs. The structure of the EFTE cushions were also being placed using a rhomboid grid of steel girders. This shape is very useful for the strength, but also in allowing individual cushions being placed across the facade. This means each cushion can be individually lit up with different colours. Here are some of the examples of the cushions being lit up to create this striking facade. Next, we must move on to the roof. The roof uses a cantilever roof. This was referred to as suspended spoke wheel roof because of program and sequence. Even though it must be commented that the suspended spoke wheel roof would have had created material savings. This roof is the largest in the world made of foil. Also, there are many weather-related safeguards that will cater for the rain and snow. This is very valuable for a sports stadium, especially in Germany where it snows in the winter. This roof is also self-cleaning and has ventilation. The Allianz Arena has a filigreed roof supporting structure that cantilevers freely for 65 meters above the supporters. This size is also very useful as it offers protection from the weather. The roof construction consists of 9,000 tons of steel, meaning 2 construction methods were used. The primary construction uses the lattice work, with the stadium core using the filigreed method. This acts also as support for the EFTE cushions. The roof lattice structure was supported by the four slabs and the column of the body, with the entire load of the roof being transferred to the foundations. Now we'll move on to the finishes of the Allianz Arena. You could consider the next 2 items the most important, the seats and the pitch. The seats consider the home of the supporters, with the pitch the home of the players. Firstly, we will talk about the seats. These seats were specifically designed for the stadium and were totally a unique creation. They are foldable and operate on an ergometric nature, meaning they will fold away on their own dependent on movement. Also, they have the same appearance as the VIP and standard seating. This will give a seamless appearance throughout the stadium and help the Allianz Arena look uniform in nature. Now, the Allianz Arena boasts a fantastic pitch, both in terms of appearance and operation. The grass is well maintained at a height of 2.3 centimetres, which is in regulation with UEFA. The pitch also boasts an underground heating, anti-frost gravel and drainage services. This means this is the main important parts of the pitch are hidden below the surface, away from the sight of everyone. Also, the pitch size is 105 by 68 metres. The flooring is also identified during this presentation. Dependent on the area you find yourself on the Allianz Arena, means you will have different flooring. In the concourse and terraces, you will find concrete flooring. This is because it is low maintenance and easily cleaned. These areas is where supporters will be situated, therefore will have a lot of traffic. Also, they are not very slippery, which is important to note in case of rain and spill drinks. Within the business club, sponsor lounges and other hospitality sections such as matchroom boxes, you'll have wooden flooring. This will give it a nice presentable image that is required for areas such as these. The stadium offers many services also. The stadium offers a business class, hospitality events, and spacious area for media. The latest equipment is given. This is very important within the World Cup being hosted in 2006. Also, the Allianz Arena offers 106 matchroom boxes, all being unique in nature, although these boxes are open 365 days a year, not just on match days. Refreshment kiosks and bars are available to all supporters. This is very important for a stadium, therefore this had to be considered during the design phases. A press conference room will allow the manager and other staff to talk directly to the media also. The Allianz Arena also boasts the largest underground car park in Europe, offering 12,000 spaces to spectators. Finally, the restaurants are there for the business club and sponsor lounge as well, meaning kitchens have to be installed on site to prepare fresh food for the paying customers. Now we must talk about the sustainability methods that were used during this project. New LED lights were installed by Philips in 2015. They were 60% more energy efficient, meaning there will be great savings to the environment. This equates to 362 tons of carbon dioxide every year. That comes to the end of the presentation. Thank you for watching my presentation on the Allianz Arena. I hope you found it interesting as well as informative.